Hello, it's Steve, and this is Brainless Raider, a puzzle adventure game made in 3 hours for Trijam 276. In this series, we're going step by step over the process of remaking the game in Bevy, the Rust game engine, in probably closer to 3 months. Alright, last time we made a basic collision system, which currently is just logging to our console when things enter and exit each other. Today we are going to leverage that system on that collision right there between the Goblinoid and the Adventurer. So let's get into it. First off, to keep things clean, this collision file is just for our collision system itself, so we really want to consume these collisions in other files, and it doesn't feel right to me to make an entire file just for that one collision, so we're just going to make a kind of general collisions module for any collisions that don't necessarily fit in another obvious feature. So we'll call this collision events, and we'll do our normal plugin dance here. So there's our basic plugin definition that we're going to use. Let's go into main and use it. There we go. Something else we actually have to do is, since we're going to be using these events somewhere other than this file, these actually need to be pub. So just a minor change there, but it would give you an angry message if we forgot it. Alright, back to our collision events. We're going to have a section for systems here, which we're going to start by just inserting a blank system that we'll talk through in a second. We're going to stick this system into the app itself. So this is going to want to be run when collision events happen, and it's going to need to use 2 queries to check for Goblinoid collisions and Adventurer collisions. Alright, a couple of things here. I think we forgot to define the Adventurer and Goblinoid tags. So let's do that first. These are what we're going to call tags. I think they can also be called markers. Basically, they're just empty structs which act as, well, markers for entities to see this is the adventurer entity, even though this adventurer struct doesn't have any data we want to mess with. As of right now, this system is looking at a collision enter that has to be mutable, because when you read an event reader, it tells the event reader that, hey, that's been read, so that it doesn't serve it to you again. So that needs to be mutable. The adventurer query, we're not going to do anything to the adventurer when he collides with a goblinoid, so that doesn't need to be mutable. However, we are going to do some things with the goblinoid, and we're actually going to need additional properties here, but we'll do that in a bit. Now, we need to define hydrators for the goblinoid and adventurer. So let's start that with the kind of silly way, and then we'll think about a better way to do it. So this would be how we would do it using our current system. So then what we could do is in our main function where we're currently registering these hydrators, we would just register goblinoid with hydrate goblinoid and adventurer with hydrate adventurer. This is a little bit annoying to have to define these basically empty functions for all of our tags. We're going to have several tag type components. I'd really rather refactor the hydrate components to also accept, instead of registering just hydrators, let's add an ability to register a tag to reduce this overhead. So next to this register hydrator, we're basically going to do something similar. We're going to call it register tag, and this takes a generic type argument. It still has the mutable self and the component name, but it no longer has the function, because we're going to build that out in a second. What we do need to do, however, is enforce that the type T is both defaultable and a component. And then instead of inserting the function with that component name, we are going to use our newly defined function, which we need to create right now. So down in helpers, let's tack in this new function. This is very similar to a hydrator because it is a hydrator. It just is a generic hydrator for some type T that implements default. And there we go. So now we can use this hydrator in the register tag function, and we can use the register tag function instead of register hydrator in these cases, which the knock-on effect of that is we don't need these anymore. So now for anything, as long as we implement default with our component, we can use a tag hydrator to just default hydrate it. That helps with these. Also, you'll note that if you remember when we were defining our adventure components and our goblinoid components, we actually already tagged in adventure and goblinoid in here. So these should automatically hydrate for us. We don't need to do anything about them. They're just going to get hydrated, and that's awesome. With that, we can start actually implementing this collision event. Let's actually start by printing something when this event happens. Let's do something a little bit weird here, and I'll explain it in a minute. Here we're checking, okay, if the adventure is entity 0 and the goblinoid is entity 1, or the adventure is entity 1 and the goblinoid is entity 0, we're going to print this. Let's run it just to see that it works. Hey, there we are. One tag for that collision. How do we stop ourselves from having to do all this? Because that is really obnoxious. Well, it would be super nice if we could align those two entities to a certain thing. So let's say we want something that returns a tuple of entity 1 and entity 2, and we want to tell it what order to have that in. So let's imagine a function that takes in those two entities and then takes in a query that will basically say which of these two entities should be in spot 1, right? So obviously that function doesn't exist, so let's make it. So let's talk real quick about the function signature here. Obviously we're passing in two entities, but we have two generic type parameters, and these are used by query itself, and we have some requirements here for TNF to be query data and query filter. So that is actually what this is. It's query data with a query filter, right? And we don't actually have to pass these two generics in because those are read basically from what the type of the thing we're passing into the function is. So that's handy. But this is basically saying that we can pass just about any query in. So let's write this function. And really, it's as simple as that. We are just checking to see if the first one is matching query first, and if it is, we'll just return it like this, assuming that E2 is something we care about. Otherwise, we'll pass that in the second place if it doesn't match. Pretty straightforward. So now we have our two entities aligned, and the first one is definitely going to be adventure. That means if we wanted to do this again, we could just... So we are making a tuple of whatever the result of this get call for the adventure query is for entity 1, and doing the same for the goblin query in entity 2, and passing those over to two OKs. So if these are both reading OK, that means that we did in fact find an adventure as entity 1, and we did match a goblinoid for entity 2. We're going to think about what we want to do when we're killing the goblinoid. So an easy thing to do just to get started would be we're going to remove its mover so it stops moving. So let's start with that. First we need to pull in commands, and then we can call the commands.entity to give us some entity commands for whatever entity we're using. For our case, we're going to use the goblinoid entity that returns here, and then we're going to remove the mover from that entity. Simple as that. So let's run this and see what happens. And now you see that the goblinoid stops upon colliding with the adventurer. That's exactly what we want to have happened from this line here. Now we could go through step by step and really talk about how we designed this, but let's just go through and code it all up, and then I can talk about what's happening. Let's run this and see what we're doing here. Alright, so you see now when the goblinoid was run over, not only does it stop moving, but it's also rotated slightly. It's smaller than it was before, which is the scale line. The translation Z is supposed to put it underneath the adventure, but that's not quite happening yet. And it's actually getting a little bit darker to showcase that it's no longer among the world of the living. In order to do that, we needed to use get mute in order to grab the mutable transform and mutable sprite. We also needed to, in the goblinoid query, not only grab the entity, but also a mutable reference to transform and a mutable reference to its sprite. So let's define a few constants so that this is a little bit easier to understand. So a couple things here. First, we're using the color gray rather than newing up a color from RGB. We're also using rotation in degrees, but here this call to rotate Z actually takes radians. So we need to do some transforming to make that work. But first, let's copy all our things over. We want to just have a quick helper here to convert from degrees to radians, so let's make that real fast. All right, there's our degrees to radians function. It's pretty self-explanatory. I mean, you can look up the math for that, but now we pass that in, and if we run, our Goblinoid should be rotating exactly 90 degrees, and things should look pretty good. And the Goblinoid does, in fact, move underneath the player after being murderized. So that works fine. We wanted to kind of do audio this time, but I think we're running out of time for that. So let's just real quick go over Z indexing. So currently the way it works is we have in our main here, we have entity Z defined. And that is getting passed to every single entity, like any non-tile is receiving that. And that's a little bit funky because we want stuff like treasure to render behind most of the movers and, some other things. We want to be able to move our Goblinoid down below the adventurer without putting it under the tiles and stuff like that. So instead of using this entity Z, let's create a methodology for using Z indexing on a per template basis. So the easiest thing to do here is actually to go to just all of the entities we're rendering and just add a Z component to them. Now, yes, this is a little bit messy because we are assuming that none of the components we make are going to need Z for any other reason, but I'm okay with that being as this is a short project. This is just one of the other trade-offs that comes with our simple component system. So basically we're going to go in here and we're just going to define Z for all of these. What we ended up with is 10 is where the player is rendered, which is pretty much on top of everything. Most things that aren't going to be really part of the map itself, like the planks trigger and teleporter, are on 5, but also a lot of middle ground things that probably aren't going to be on top of each other, like the enter portal, exit portal, and the exit itself are all on 5 as well. Pit is on 1, so that's the lowest that we have here, and then planks is on 3, which is above that and under most other things. Goblinoid's on 7, and treasure's on 6, which is below both of the movers, but well above most of the other stuff they move over. So that should look just fine. Now we also just need to adjust our map parser to heed this Z address or index. In object data here, we have an X and a Y. Let's also add in a Z. And this one's going to be an F32. And down in the creation of the map server, where we're parsing these properties from the templates, what we want to do is just tack in right here a default Z value, and then if we find a Z, we'll override it. So here we're just going through our template properties, and if we find one, assigning it to Z. And then we can just pass Z in right here. In main, instead of entity Z, let's keep this around, but let's just make it entity Z offset, just to give every entity a little bit of a buffer between the entities layer and the tiles layer. And then instead of using entity Z here, we're going to use the objects Z that we just defined plus the offset. So let's see how that looks right now. We broke it. Where do we break it? Movement. Right, so here we're doing the entity Z, but what we actually just want to do is grab the transforms Z, because we're not going to be changing this transforms Z at all, so it's always going to be wherever it is currently, basically. And if we do change it, it'll be an immediate change, like when we moved the Goblinoid down. And what else is it mad about? We don't need to pull this in anymore, because it doesn't exist. With that, everything's more or less going where it needs to go right now, right? And even our adventure is rendering over top of the things it's supposed to be rendering over top of, like the exit. That looks a whole lot better. I'm glad we included that in this video. So next time we're going to get our audio server up and running, and then use that for a death sound, which we already have. Well, no, we don't, but we have it somewhere. It's on our computer somewhere. We'll have to find it. That's about it. Thanks for watching. Peace.